Today we'll discuss about the types of artificial intelligence and the threats which AI offers to us. Artificial intelligence can be divided based on its functionalities and capabilities. Under functionalities, we have four types of artificial intelligence, named as reactive machines, limited theory, theory of mind and self-awareness. While there are three types of artificial intelligence based on its capabilities which are narrow AI, general AI, and super AI. So, first we'll discuss the stages or types of AI based on its capabilities. Artificial narrow intelligence or ANI is also referred to as narrow AI or weak AI. It is the only type of AI that is achieved to date. Weak AI or narrow AI is specifically goal-oriented, that is designed to perform singular tasks such as face recognition, driving car, speech recognition, voice assistance, or browsing the internet. It is very quick and accurate at completing the specified task for which it is programmed to do. It is referred to as weak AI because though the machines look intelligent but they function under a narrow set of constraints and limitations. Narrow AI cannot replicate human intelligence, it just simulates human behavior which is based on a narrow range of contexts and parameters or factors. The examples of narrow AI include RankBrain by Google, manufacturing and drone robots, IBM's Watson, Siri by Apple, Alexa by Amazon, Cortana by Microsoft, and other virtual assistants. It also includes disease mapping and prediction tools, image or facial recognition software, recommendations that are based on listen, watch or purchase history, etc. This is the only AI in existence today, for now. Artificial General Intelligence, AGI, also referred to as strong AI, possesses general intelligence that can mimic human behavior or intelligence and is capable of learning and applying this knowledge to solve any problem. AGI is capable of thinking, understanding, and acting in a way that is identical to humans in any given scenario. AGI is not yet achieved by AI researchers and scientists. To achieve AGI, they need to program all the cognitive abilities into the machine. Machines are required to take up experimental learning to the higher levels, and apart from improving efficiency in singular tasks, they also need to be capable of applying knowledge to a wider area of solving problems. Fujitsu built K computer, one of the fastest supercomputers, is one of the most notable attempts at achieving strong AI, but considering it took 40 minutes to simulate a single second of neural activity, it is difficult to determine whether or not strong AI will be achieved in our foreseeable future. The immense challenge of achieving strong AI is not surprising when you consider that the human brain is the model for creating general intelligence. The lack of comprehensive knowledge on the functionality of the human brain has left researchers struggling to replicate basic functions of sight and movement. Artificial superintelligence is the hypothetical AI that doesn't just mimic or understand human intelligence and behavior. Superintelligence is where machines become self-aware and surpass the capacity of human intelligence and ability. In addition to replicating the multifaceted intelligence of human beings, superintelligence would theoretically be exceedingly better at everything we do: math, science, sports, art, medicine, hobbies, emotional relationships, everything. Superintelligence would have a greater memory and a faster ability to process and analyze data and stimuli. Consequently, the decision-making and problem-solving capabilities of superintelligent beings would be far superior than those of human beings. Now, let's discuss the types of AI based on its functionalities, which are reactive machine, limited memory, theory of mind and self-awareness. The most basic types of AI systems are purely reactive, and have the ability neither to form memories nor to use past experiences to inform current decisions. Deep Blue, IBM's chess-playing supercomputer, which beat international grandmaster Garry Kasparov in the late 1990s, is the perfect example of this type of machine. Deep Blue can identify the pieces on a chessboard and know how each moves. It can make predictions about what moves might be next for it and its opponent. And it can choose the most optimal moves from among the possibilities. But it doesn't have any concept of the past, nor any memory of what has happened before. Apart from a rarely used chess-specific rule against repeating the same move 3 times, Deep Blue ignores everything before the present moment. All it does is look at the pieces on the chessboard as it stands right now, and choose from possible next moves. This type of intelligence involves the computer perceiving the world directly and acting on what it sees. It doesn't rely on an internal concept of the world. Similarly, Google's AlphaGo, which has beaten top human Go experts, can't evaluate all potential future moves either. Its analysis method is more sophisticated than Deep Blue's, using a neural network to evaluate game developments. These methods do improve the ability of AI systems to play specific games better, but they can't be easily changed or applied to other situations. These computerized imaginations have no concept of the wider world, meaning they can't function beyond the specific tasks they are assigned. A limited memory machine, as the name might suggest, is able to retain some information learned from observing previous events or data. Self-driving cars, for instance, store pre-programmed data like lane markings and maps, alongside observing surrounding information such as the speed and direction of nearby cars, or the movement of nearby pedestrians. These vehicles can evaluate the environment around them and adjust their driving as necessary. Improvements in artificial intelligence also helps autonomous vehicles to continue to learn how to drive in a similar way to humans, through experience over time. Theory of mind AI represents an advanced class of technology and exists only as a concept. Such a kind of AI requires a thorough understanding that the people and things within an environment can alter feelings and behaviors. It should understand people's emotions, sentiments, and thoughts. Even though many improvements are there in this field, this kind of AI is not fully complete yet. The Kismet robot head, developed by Professor Cynthia Braziel, could recognize emotional signals on human faces and replicate those emotions on its own face. Humanoid robot Sophia, developed by Hanson Robotics in Hong Kong, can recognize faces and respond to interactions with her own facial expressions. However, there are still a number of hurdles to achieving theory of mind AI, because the process of shifting behavior, based on rapidly shifting emotions, is so fluid in human communication. The most advanced type of artificial intelligence is self-aware AI. When machines can be aware of their own emotions, as well as the emotions of others around them, they will have a level of consciousness and intelligence similar to human beings. This type of AI will have desires, needs, and emotions as well. They will be able to make inferences, such as "I'm feeling angry because someone cut me off in traffic," that are not possible with other types of AI. We haven't developed this type of sophisticated AI yet and don't have the hardware or algorithms to support it. As AI grows more sophisticated and ubiquitous, the voices warning against its current and future pitfalls grow louder. Whether it's the increasing automation of certain jobs or autonomous weapons that operate without human oversight. In the last few years, several high-profile voices, from Stephen Hawking to Elon Musk and Bill Gates, have warned that we should be more concerned about possible dangerous outcomes of supersmart AI. Elon Musk issued a friendly warning: "Mark my words, AI is far more dangerous than nukes." The outspoken Musk has repeated a version of these artificial intelligence premonitions several times. "I am really quite close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential." The late physicist Stephen Hawking also said that unless we learn how to prepare for, and avoid, the potential risks, AI could be the worst event in the history of our civilization. But for many, such fears are overblown. As Andrew Ng at Stanford University, who was a co-founder and head of Google Brain and was the former chief scientist at Baidu, said that fearing a rise of killer robots is like worrying about overpopulation on Mars. So, is artificial intelligence really a threat to our civilization? Please tell us about your views in comment section.